Good morning and good afternoon. My name is Vamshida Parupalli and I'm excited to present CalamanCy, a Tagalog natural language processing toolkit. So the motivation for this work, NLP has made significant progress in high resource languages like English and Chinese, but languages such as Tagalog, despite being spoken by over 28 million people, remain underrepresented. The main problem is a lack of task specific high quality resources, particularly for name entity recognition, which is foundation for applications like question answering, translation, and information extraction. Our goal was to fill this gap and provide reproducible, high quality tools for Tagalong. So our work makes four key contributions. First, we created TL Unified, the first manually annotated dataset for Tagalong name entity recognition. Second, we achieved high inter-annotator agreement with a coherence kappa of 0.81, which ensures reliability. Third, we benchmarked a range of models from baseline to multilingual and monolingual transformers, establishing reproducible results. Finally, we released CalamanCy, an open source toolkit that integrates both the dataset and models, enabling community to build upon our work. To build the dataset, we curated news articles from TL Unified corpus spanning from 2009 to 2020, ensuring diverse topics like politics, science, and culture. We focused on three core entity types: person, organization, and location. The annotation process involved three native Tagalog speakers working with the Prodigy annotation tool hosted on Google Cloud. The process was iterative with multiple rounds and retrospective reviews to refine the guidelines and increase consistency. The result is the dataset that is both reliable and representative of the modern language. Next, we evaluated a range of models on the dataset. The SPACY baseline achieved an FN score of 71.2 and FastText embedding improved this to 76.5. Multilingual models such as Embed and XLMR achieved scores around 78 to 80, but the best performance came from monolingual Tagalong Roberta model, which reached an FN score of 82.3. For comparison, large language models tested in a zero-shot setting achieved up to 64.8, which is promising but still far below supervised fine-tuning. Our experiment highlighted several key insights. Contextual embeddings consistently outperform statistic ones. Monolingual Tagalog models outperform multilingual ones, showing the importance of the language-specific pre-training. The main challenge for all models was distinguishing between organizations and locations, which often share surface similarities. However, context-rich embeddings significantly reduce these errors, emphasizing the value of contextual information. To conclude, we present TL Unified, the first Tagalog NER dataset, and the CalamanCy toolkit. Together, they establish a foundation for systematic progress in Tagalog NLP that can be used for the community, and it can be used to develop on as a base. And for the future work, we plan to expand the dataset with finer grained entity types, extend annotations to other major Philippines languages, and explore optimization techniques, and also on the prompt based adoption of the large language models. So our broader goal is to reduce the gap between the high resource and the low resource languages for the better representation in the global NLP landscape. And thank you so much for the presentation. Thank you.